Welcome to Why, where we ask the questions that unlock the secrets of the universe.
From the world of astronomy. From the potato chips to post-it notes, some of life's greatest discoveries have been accidental. Serendipitously, the same applies to the universe. From super-Earth and Sun twins to alcohol-spewing comets, the extraordinary efforts carried out by scientists and astronomers have led to mind-blowing discoveries in outer space. One such astronomical discovery, albeit an accidental one, changed science forever. The first of its kind, this mysterious discovery, initially called PSRB 1257+12b, and later named Poltergeist, confirmed the existence of planets outside our solar system. The men behind this feat were Penn State Exoplanet astronomer Alexander Wolszczyn and his colleague David Frail. Although their paper, published on January 22, 1992, stated the existence of this exoplanet quite conclusively, the discovery was accidental. The duo was looking for pulsars, and had spent much of their time, in the 1980s and 1990s, doing so. Pulsars are powerfully magnetized, rotating, neutron stars, that produce intense beams of light, that we on Earth detect as flashes or pulses. What is fascinating about them is that they are extremely accurate in their periodic pulsing, so much so, that they are used for navigation in deep space. They act as space beacons, similar to lighthouses on Earth, helping guide spacecrafts through the cosmos. But due to their violent formation in the heart of supernovae explosions, no one believed that they could have harbored planets. But they did. Wolszczyn was a pulsar hunter and a resident pulsar radio astronomer at the Arecibo Observatory in Puerto Rico, in the 1990s. In support of his work, and to search for millisecond pulsars beyond the Milky Way's galactic disk, he was given complete, and sole charge to use the large dish, for 2 months in early 1990. Time and effort paid off, and Wolszczyn found 2 pulsars, out of the galactic plane, one of which, PSRB 1257+12, about 2,300 light-years away, in the Virgo constellation, seemed to have some irregularities in its timekeeping. Astronomers had been on the watch for exoplanets, much before the time Wolszczyn came across his own. Most of them used the radial velocity method, which involved watching the spectra of light, emitted by stars over time for a wobble, in their motion with much precision. The wobbles are indicative of the tug of an orbiting planet. Although Wolszczyn was not using the radial velocity method, he paid very close attention to the pulsing behavior of Poltergeist. He observed it, and timed the emissions of the pulsar, over a certain period of time. This indicated its precise rotation period. Wolszczyn knew that Poltergeist was most likely a part of a binary system, that is, a pulsar in mutual orbit, with a white dwarf, or similar star. And that is why he kept a close watch on the companion star's gravitational influence on Poltergeist's pulse. What he noticed was that the pulsing of Poltergeist was not precise, as it should have been, if its companion was indeed a white dwarf star. He came to the conclusion that because the variations in pulsar timing are extremely sensitive to change, when there are other massive objects present, he was most certainly dealing with other objects in the system. The paper published by Wolszczyn stated the presence of Poltergeist and its companion Phobeater, both of which were about 4 times the mass of Earth. 2 years later, another exoplanet was detected by Wolszczyn and Maciej Konecki. It was the smallest exoplanet known thus far, only about twice the size of the Moon. It was named Drauger. Till date, astronomers are looking for answers to understand how Poltergeist and its companions were formed. One theory says they could be the congealed remains of Poltergeist shredding passing stars. But nobody knows for sure. Having said that, science has advanced tremendously since the discovery of Poltergeist in 1992. In 1999, astronomers successfully used the transit method, which involved observing the stars for dips in their brightness as planets passed in front of them. This led to the discovery of HD 209458b, or OSIRIS, making this technique popular in the hunt for exoplanets. Ever since then, we have made several space telescopes. The Hubble, which is called the father of space telescopes, has been in service for decades, and sent stunning pictures back to Earth. Now, the James Webb Space Telescope, built on past data and future expectations, is going to look for the mysteries of the early universe, hunt out exoplanets, and see if they can harbor life. Drop in your comments to let us know.